On page 12, we are going to discuss surds. And first of all, we must understand what are surds. If n is an integer that is not a square number, and what is a square number? A square number is like 1 because 1 squared is 1, like 4 because 2 squared is 4, like 9 because 3 squared is 9, and so on. And if n is an integer that is not a square number, then any number of root n is called a surd. And for example, root 2, because 2 is not square. Root 5 is not a square number. Root 10 is not a square number. Root 20 is not a square number. All those are surds, because we do not have a terminating square root for 2, a terminating square root for 5. We do not have terminating square roots of these numbers. And surds are examples of irrational numbers. And we remember that we understood what irrational numbers are. And one of the major features of the irrational number is that when you write them in decimal form, they do not terminate and they do not repeat. For example, the square root of 2, if you consult your calculator, is going to be 1.4142 135 moving forward, and it doesn't repeat at any particular point. So this is a perfect example of a surd. You can use surds to write exact answers to calculations, and of course there are two rules here we are going to manipulate and understand: that the root of any number ab is the same as the root of a times the root of b. You simply separate them. And the root of a over b can be written as the root of a all over the root of b. These two rules, we are going to use them so much in this particular subtopic. And I want us to go straight to example 12. Example 12 part A, and we are supposed to simplify the root of 12. What do you mean by simplify? We need to rewrite root 12 probably using law 1, and there is law 2 here. We separate 12 in two numbers such that one of the number is a highest factor of 12 that is a square. A highest factor of 12 that is a square. 1 is a factor of 12 because 1 times 12 is 12. 2 is a factor of 12 because 2 times 6 is 12. But between 2 and 6, none of them is a square. 3 is a factor of 12 because 3 times 4 is 12. But if you rewrite this one in terms of, you realize that root 4 times root 3 is simply root 12. And we are going to use 4 because 4 happens to be the highest factor of 12 that is a square. So in this case, the root of 4 is 2 times root 3, which is going to give us 2 root 3. The secret here is we have to have the highest factor of this number that is a square. Squares, we said, are like 1, 4, 9, 25, 36, 49, and moving forward. Those are the squares. So don't forget this. When you are simplifying surds, you have to look for the highest factor that is a square. The highest factor of that number that is a square. Let's look at part B. Part B talks of root 20 over 2. Root 20. That is part B. Part B, the root of 20 divided by 2. Only 20 is affected by the root here, so we have no issue with the 2. And what are the factors of 20? One of them has to be a square. It's not 2. Let's look at 4. 4 times 5. It's not, let's look at 4. 4 could be the one, but let's go to 9. 9 is not a factor of 20. Let's go to 16. 16 is not a factor of 20. So obviously 4 becomes the factor of 20. And of course we talk about root 4 times root 5 over 2. But what is root 4? It has a perfect square root, which is 2 root 5 over 2. 2 and 2 cancel out, and eventually we are having our solution as simply root 5. Let us look at part C rather. Let us look at part C. Part C talks of 5 root 6 minus 2 root 24 plus root 294. Root 294. There is nothing we can do as far as root 6 is concerned, because there is no factor of 6 that is a square. So we just write it 5 root 6. What about 24? We have to consider 4 is a factor of 24 and 4 is a square. 9 is not, 16 is not, so obviously we are going to have 2 root 4 root 6 times root 6, because again 4 times 6 is 24. We have some work here. We need to find factors of 294 that is a square, and we have to start down there. Is 4 a factor? So 294 divided by 4. Is it a factor? It's not. So we go to the next one. Is 9 a factor? 294 divided by 9. It's not. We go to the next one. 16. 294 divided by 16. It's not. It's not a factor. So let's talk about 25. 25 obviously is not, because our number ends with 4. It's not. So let's go to 36. Is 36 a factor? It is not. Why are we saying all those are not factors? Because they are not giving us whole number quotients. Of course, let's go to 49. 294 divided by 49. Is it a factor? Yes, because 49 times 6 is going to give us 294. So we separate this one and write it in terms of factor, root 49 times root 6. At that point, we only need now to simplify and have 5 root 6 minus 2 times root 4, which is, this root 4 is 2, so minus 2 times 2 minus 4 root 6 plus root 49 is 7 root 6, and collecting the like terms, all of them have root 6, root 6, root 6. What does that mean? If we consider root 6 to be anything like oranges, so we have 5 oranges minus 4 oranges plus 7 oranges. So in a nutshell, we are going to have 5 plus 7, we have 12 oranges minus 4 oranges, which is 8 oranges. So the final answer is 8 root 6. So please note, what we have learned here is that for us to simplify SAD, we have to look for the highest factor of that number that is a square, and that's what we have realized, and you will always be home. All right.